For many centuries, humans were torn between two opposing views of nature. First, the universe obeys fixed and immutable laws. The other believes that there is no such thing. Instead, all is flux or change. As the Greek philosopher Heraclitus said, you cannot step into the same river twice. Through Newton's mathematics, a significant step was found toward the worldwide view that unites both rigid law and flexible flux. Newton and before him Galileo and Kepler realized that change obeys rules. Not only can law and flux coexist, but law generates or causes flux. Newton's basic insight was that changes in nature can be described by mathematical processes. Stewart explained how the motion of a cannonball fired out of a cannon helps us towards Newton's second law of motion, that force is equal to mass multiplied to acceleration. Newton, along with Leibniz, invented calculus to help work out solutions to moving bodies. Calculus is the mathematical study of how things change. It has two basic operations, which means given one element, which is either force, mass, or acceleration, you can work out the other two. First operation is differentiation. It is the technique for finding the rates of change or the description on how one quantity changes in relation to another quantity. Differentiation is the rate of change that uses slope as a function. On the other hand, integration is the technique for undoing the effect of differentiation in order to isolate out the initial variables. Integration determines quantities like areas and volumes under changing conditions. For realization, mathematics does not cause anything in this world. The world does not know mathematics. These are all creations of the human mind. Basically, mathematics is just a tool which helps us describe various real-world and abstract concepts. By using different mathematical tools, one can establish how various concepts are interrelated with each other. If that is the case, why did people want formula in the first place? Why are they so observant? It is because in the early days of dynamics, that was the only way to work out what kind of motion would occur. Nowadays, it can be obtained from theories that deal directly and precisely with the main qualitative aspects of motion. The chapter of this book, The Constants of Change, proves that numbers is not static, rather it is dynamic. It is always open for change. This is most applicable in temperature, person's age, measurements, motions, date, quantity, and mostly everything.